All right, let's look at this problem of the sliding ladder. So we have a 17-foot ladder that is placed against a building. The base of the ladder is slipping away from the building at a rate of 9 feet per minute. Find the rate at which the top of the ladder is sliding down the building at the instance when the bottom of the ladder is 8 feet from the base of the building. So I've drawn this little picture here. We have our 17-foot ladder leaning against the building. It's slipping out away from the building at a rate of 9 feet per minute. And they want us to find the rate at which the ladder is slipping down the wall when X is 8 feet. So when the ladder is 8 feet away from the wall at the bottom, at the base. Okay, so let's remind ourselves that this time X is a function of T and Y is a function of T. So we'll be using implicit differentiation in order to solve this problem. Okay, so implicit differentiation implies we need to derive something, right? So what we have here is we have a right triangle. So in the Pythagorean theorem, we would have our x squared plus y squared equaling our ladder squared, right? And we also, in the very first step, we're just going to take the derivative of both sides. So let's start by taking the derivative with respect to t of both this function x of t that is squared, this y of t that is squared, and also this scalar value here. Okay, so we're going to use the chain rule. We have to take the derivative of the outside function, leaving the inside alone, and then multiply by the derivative of the inside function. We will take the derivative again with respect to t of this y function. So we have a chain rule again, derivative of the outside function, leave the inside alone, and then derivative of the inside function, dy dt. And that's going to equal 0. And now we want to, well, let's think about it. They want us to find dy dt. And we currently know dx dt and x. So in order to fully find dy dt, we also need y. So what is y is another question that we have here. So let us first completely solve for dy dt by subtracting the 2x dx dt term. And then we will divide by the 2y. Which does simplify to negative x over y times our dx dt. So once we know y, we can complete that process. So let's switch gears and find y, right? So in a second step, and you could have done this one first, but do not use y when you're taking your derivative. only use y after you've found an equation with dx dt and dy dt. Then you can find y and use y. All right, so again, we're going to rely on the Pythagorean theorem. And this time around, we will plug in the 8. So we have y squared is 17 squared minus 8 squared. Let me take a step back for a second. Okay, so to begin with, because we didn't actually plug it in, that's just take away x squared. Subtracting x from both sides. Now I'm going to subtract 8 squared. Okay, so let's see, 17 squared is not something on the top of my head. Let me use my calculator. 17 squared is 289. Take away 64, which is 225. Which actually is the square root. The square root of which is 15. Okay, so note to self, we are choosing the positive value. So first of all, we had y squared equals 225. And then what I did was I used the square root principle to take the square root of both sides. That led us to y is plus or minus the square root of 225. But since we're dealing with a distance, distances are positive. Okay, so since it's a distance, we chose the positive, and it turns out that y is 15. So if we fill out now what is our dy dt, we would plug in 8 for x, a 15 for y, and our dy, our dx dt was 9. So our dy dt is negative 72 over 15. This does reduce by 3's, right? So let's actually step back and reduce it because I'm out of space. That's why I stepped back. Okay, so if we reduce by 3, we have a 5 on the denominator and a 3 in the numerator. That then leads me to negative 24 fifths. Okay, so let us answer their question. dy dt is, the ladder is falling, so negative. It's falling 24 fifths of a foot per minute, foot per minute.